Good afternoon, ladies and gentlemen. It's Mr. Hoopert speaking, and we are doing Unit 8, Note 5, solving radical equations. I can solve radical equations. So just to remind you, all right, radical equations are going to have a square root, all right? So the first thing you're going to have to do is get the square root by yourself, all right? You have to isolate it, get it by itself, and then you can square both sides, all right? Solve for the variable. The square root of x has only a positive solution. So remember, we have to have positive solutions. So what that looks like is a bunch of examples. So let's talk about them. So square root of x minus 7 equals 0. So now look at this. Square root x minus 7 equals 0. The square root of x is not by itself. We have to get rid of the 7. So we add 7. This is still going to be square root x equals 7. At which point, the opposite of a square root is a square and a square. So then x is going to equal 49. So first things first, I had to isolate the x, get it by itself, so I added the 7 to get rid of the subtracting 7, right? And then the opposite of a square root is squared. So in this one, alright, this one's a little bit tricky, but we are solving for the x. So technically, the square root of 3 is fine. I know that the two square roots aren't by themselves, but the square root of x is. So we would just square it. And what we would do when we square it is we square everything on the right side as well. So I would argue that square root and square cancel out, so I have x. 2 squared is 4. And the square root of 3 squared would just be 3. So I would argue that x would equal 12 here. Alright, if you're super confused, that's fine. Alright, a lot of the Unit 8 Notes 1 stuff was doing the square roots, so you should be pretty comfortable with square roots and kind of understand what's going on. So, looking at this one, this is another good example. We have to get rid of the 3 first. Divide by 3. Now I have square root x plus 4. That is alone on the left. I have 5. Now is when we get to square it. So that gets rid of the square root sign. So we have x plus 4 equals 25. I subtract 4. X equals 21. Now when I look at this, right, our original equation was 3 square root. So if I plug the 21 in for x, this should work. So I have 3 times the square root of 25, which equals 15. So I have 3 times 5, which equals 15. So 15 equals 15. This answer checks off. Right? So whenever you want, you can check your answer all the time. But you don't have to. I mean, you can live on the edge a little bit. If you're trying to get an A in the class or on the quiz, you should check some of your answers. Looking at this one, it looks like square root's right here, so I got to get rid of the 8. So cross off the 8, cross off the 8. Now I have square root x minus 3 is going to equal 2. At which point, I can square this and square this. I'd have x minus 3, 4, add the 3, add the 3. So I get x equal to 7. So pay attention to what you're doing. Alright, and try to isolate that square root. Once it's a square root by itself, then you can move on. This one, looks like they put a plus 9 here to confuse me. So the opposite of the adding 9 is subtracting 9. So I would get 2x minus 3 square root equal to negative 4. You square and square it. Alright, 2x minus 3 would equal 16. Now, you guys all get this wrong because you have to know a negative times a negative is a positive no matter what. At this point, I could add 3. You get 2x equals 19. Divide by 2. And x equals, I get 9.5. Now 9.5 to me is a little bit goofy, so I might try to plug it back in. Alright, 2 times 9.5 minus 3 square root plus 9 is equal to 5. Now when I do that, I get square root 19 minus 3 plus 9 is equal to 5. I get square root 16 plus 9 equals 5. And I get 4 plus 9 equals 5. Alright, looking at this, you should see this, and this is not true. 13 cannot equal 5. So, I would probably write on this one, no solution. Right? Not those values don't work. Right? So you guys see that and go, okay, that number's smaller. I could have actually have stopped right here. Right? When you saw the square root of 2x minus 3 is going to equal negative 4, this is a negative number. There's no square root that's ever negative. We tell you to write no solution if you take a negative square root of something. So you could have been done right there at this step where I started to give you a little hint, but in yellow I rewrote it. So check your answers and make sure you don't have the wrong negatives. Going up here, let's add 2. Add 2. You are going to get square root 3x plus 1. This cancels. I'll just color over it. 8. Okay, I'm alright with that because that's a positive number. So square, 3x plus 1 equals 64. Subtract the 1. 3x equals 63. Divide by 3. X equals 21. So I would argue 21 is a really good answer, alright? So make sure you're looking for those negatives. The square root is never going to be negative, so that's going to be a no solution one for that example number 5. And I showed you that it was no solution twice, in yellow and when we checked our answer in purple. Alright, looking at number 7, I see a nice number 5 that I can divide by. So then I have x plus 1 square root equals 1. Square, I have x plus 1 equal to 1. Subtract 1, x equals 0. I like it. Easy peasy. Looking over at this one, minus 5. Alright, so now we have 3 square root x minus 4 equal to 18. Now this is kind of another step one where you actually have to divide both sides by 3 first, and finally the square root of x minus 4 is isolated by itself. This is the first time that we are able to square this answer. You have x minus 4 equal to 36. Add 4. I get 40 equal to x. Alright, extraneous solution. Sometimes we get a solution derived from an equation that is not a solution of the original equation. We have to plug them back in to the original equation to see if they work. So this is what I've been doing a few times to show you there was a no solution once, right? And then I showed you that it worked as well. Alright, so you got to check some of these answers, and we can talk about why. Alright, so let's look at number 9. We get square root of x plus 2. Alright, so that x plus 2 is by itself already. So I would argue this is x plus 2 equals x squared. You guys aren't going to like this because I would subtract the x, subtract the 2. I'm going to have 0 equals x squared minus x minus 2. When I do that, I should be able to factor it. 1 times negative 2 is negative 2. And this is negative 1. So I would argue negative 2 times 1 would be how I'd split this up. So since this coefficient of a is 1, you can actually just look at your values, and this needed to be x minus 2, x plus 1. Now, if x minus 2 equals 0, then x is equal to positive 2. If x plus 1 is equal to 0, x is equal to negative 1. Now, what I would do with those is I would check these. So up here, I'll check them. Take this equation. 2 plus 2 is going to equal square root of 4 Oh, I better do it this way. Is equal to 2. So then the square root of 4 equals 2, and 2 equals 2. That's true, so this one checks off. Now if I had negative 1 plus 2 equal to a negative 1, this is going to be square root of 1 equals negative 1, 1 equals negative 1. That one is not true, so we would cross this answer off. So the only x equals negative 1 is an extraneous solution. The only answer we want is this x equals 2. So write x equals 2. Don't include both of them. If I look at this one, square, square. So I get 4x minus 3 equal to x squared. Just like the last one, we're going to subtract the 4x, add the 3, and now we have 0 equals x squared minus 4x plus 3. When I look at that for my x factor, 3 times 1 is 3, b term is negative 4. I know that it's negative 3, negative 1. So, if you're good, this GCF here is 1, so I can just look at my x method and see that I need these two equations here. Now, x minus 3 and x minus 1. So, x minus 3 equals 0. If that were to be the case, you'd add the 3, x equals 3. Alright, the other one would have been x minus 1 equals 0. Add the 1, x equals 1. So then we got to check these. So we pick this up, we go 4 times 3 minus 3 equals, and then I'll put in a 3 for the other x. So this is the square root side. Alright, so I'd have square root 12 minus 3, which is the square root of 9, which is equal to 3. So all this ends up equaling 3. This is true. X equals 3 checks. Then we'd have this other one, x equals 1. So maybe down here I go 4 times 1 minus 3, and the square root equals 1. I get square root 4 minus 3 equals 1. I get square root of 1. So in this one, both of them checked out. So I don't know how much you need to plug in. I don't know how much work you individually need to show. I do know that you need to check when we're doing square roots that we don't have negatives, because a negative square root is not going to work. So the perimeter of a rectangle is 20 feet. Its dimensions are 4 and x1. Find the value. So if I looked at this rectangle, I would say maybe this is 4, square root x minus 1, square root x minus 1. So when I look at this, I would have said this is square root x minus 1 plus 4 plus square root x minus 1 plus 4 is going to equal 20. Now, actually, if I have square root x minus 1 plus a square root of x minus 1 plus 8 equals 20, notice I put these two together. When you can do that, 4 plus 4 is 8. So 1 square root of x minus 1 plus another 1 is actually going to be 2 times square root x minus 1 plus 8 equals 20. And then now this is something that we looked at. So perimeter is adding all of them up all the way around. So I started that in that top line here. Alright? Then you got to know that one of these plus another one lets you put a coefficient of 2 out front. And now this is something that we've been working on solving. This is probably just a two-step one, right? Because when I look at this, I'm going to have 2 times square root x minus 1 equal to 12. This is the one where we got to get rid of the coefficient of 2. So now I have square root x minus 1 equals 6. At which point, let's square some stuff. I'm going to write it over here. So I get x minus 1 equals 36 plus 1 x equals 37. Great work. You can tell I messed up my picture, right? Because if I put 37 in here. 37 minus 1 is 36. So I take the square root of 36, and that equals 6. So according to my picture, I have 6 and 6 and 4 and 4. That works. They would add up to 20 all the way around, but I got my short side to 6. Common mistake. At least we understand what we're supposed to do and how the algebra works. All right, next one. The formula for velocity of a moving object is velocity equals the square root of 2e over m, where E is the kinetic energy in joules. So E is kinetic energy in joules. M is the mass in kilograms. And then V is velocity meters per second. What is the kinetic energy of an object that is moving 6 meters per second? So meters per second, right, that's a velocity, and a mass of 9 kilograms, right? That is a mass of 9 kilograms, da-da-da-da. So we are going to find the formula for moving object. So we want to solve this for E here. So E is not by itself. So let's try and rearrange this so that it's by itself first. So what I would do is I'd take a pencil and I would square both sides. So velocity squared is going to equal 2e to the m. So what's the opposite of dividing by an m? I would have said multiply by an m on both sides. Multiply by m. Then you'd have m times velocity squared is equal to 2e. I'd divide by the 2, and this would be this. So my final equation, I am solving for E because it wants kinetic energy right here. So kinetic energy is that. So they're both blue. So I got to do mass times velocity squared divided by 2. So now I'd sub in what I know. All right, the mass is 9 kilograms. The velocity is 6 meters per second squared, and that needs to be divided by 2. What I'd probably get in my calculator is I'd probably do 9 times 36. If you square the 6, it's that, divide by 2. Then I would probably get 162 if you did that correct. Oh boy. 162. So this is 162. And as a lazy mathematician, we just need to know it's in joules. So we'll say joules. The kinetic energy was 162 joules. This is pretty cool here. Alright? This step here, all this stuff, moving it without it, alright? You can rearrange any formula you get in math before you plug in the values. That stuff circled in black is the only way to do one of your problems in Unit 9. So if you start picking up on this, if you're doing stuff in physics, right, manipulating equations is just algebra. So if you want to do that, go ahead. All right, thanks for listening. Have a great day.